These past few days, we've been working with estimating and measuring weight and capacity. Today, we're going to be working on real-world problems that help us make sense of how we use measurements in the real world. Today, we are focusing on using our math story problem-solving steps and thinking, or math stories protocol, reading and visualizing, representing and retelling, and solving with our best strategy. Remember today to always include your units of measurement. Let's take a look at the problem. What are we trying to find out today? Say your answer out loud. Yes, we're trying to find out how much a pet hamster weighs. So we can call this our big question. What do we need to know? Say your answer out loud. I heard friends say that we need to know how much this mouse weighs. Why do we need to know how much the mouse weighs in order to find out how much the hamster weighs? Say your answer out loud. That's right. We need to know how much the mouse weighs because in the story, it says that a pet hamster weighs 126 grams more than a mouse. That tells us in order to find the hamster, we have to know the weight of the mouse first. We can consider the weight of the mouse to be the little question. We know that great mathematicians are always thinking, what do we need to figure out? And are there little questions that we need to figure out first? What do you notice about the scale? Say your answers out loud. That's right. We notice that the scale is measuring in grams, that's our unit, and that we have some numbers that are labeled and lots of hash marks and intervals that are not labeled. How can we use the existing intervals to help us find out what each interval represents? Think to yourself, then share your answers out loud. How can we use existing intervals to help us figure out what each interval represents? I heard you say that just like we've been doing in previous lessons, we can use the intervals that are given to us to help us figure out the intervals in between using our skip counting or multiplication. Let's try that. I see that the large black interval right here means 250 grams, and that's the 1, 2, 3, 4, 5, fifth large interval. So we can think, what number can we count by 5 times to get to 250? Another way to think about that is 5 times what equals 250? Let's try counting by 50s. 50, 100, 150, 200, 250. That works. What do you think each dark interval is counting by? Say your answer out loud. I heard you say 50s because if we count 50, 100, 150, 200, 250, it matches with our intervals. Nice work. Now that we have the large intervals labeled, how can we use that information to help us find out how much each smaller interval is counting by? Say your answer out loud. I heard you say that since it starts at 0 and the next labeled interval is 50, we can skip count 1, 2, 3, 4, 5 times to get from 0 to 50, or we can think 5 times what equals 50, just like we did before. What do you think each small interval is counting by? Say it out loud. I heard you say 10, because if we count 0, 10, 20, 30, 40, 50, we can count by tens 5 times and get to 50. Nice work. Let's use this information to help us find the weight of the mouse. If the mouse weighs this much, how can we use our skip counting by tens to help us? Say your answer out loud. That's right. We know that this large interval is 250 and each smaller interval counts by 10. Let's count on from 250 up by tens. 260, 270, 280. So we can say this mouse weighs 280 grams. Nice work, team. Thanks for working together to help us visualize what's happening in the story by marking up and annotating our scale or our picture. Whenever you see a scale or a beaker or an image shown, it's so important to think, what information is this image giving me, and how does that help me understand my story? Let's keep going. How do you represent this problem? Say your answer out loud. I heard friends say that they represented using a tape diagram. They wrote that M, the weight of the mouse, plus 126 grams, which is the amount more that the hamster weighs, is going to give us H, the weight of the hamster. Why does this representation make sense? Go back to the story. I heard you say that this matches the story because we're trying to find the weight of the hamster. And we know from the story that the hamster weighs 126 grams more than the mouse. We have to add or put together the mouse's weight with the amount more in order to give us the weight of the hamster, because we know the hamster has to weigh more. Nice work. How could we show this representation in an equation? That's right. We could write 126 plus M equals H. How did you solve 126 plus M equals H? Say your answer out loud. Nice work. I heard you say that first we need to add the mouse's weight into our equation because that was the little question that we found out first. 126 plus M, 280, is going to give us the weight of the hamster. How did you solve 126 plus 280? Great work. I heard friends say that they solved using a strategy that works for them. Some might have used expanded notation, some might have used flat sticks and dots, or some other addition strategy. based on your addition work, how much does our pet hamster weigh? Yes, that's right. The pet hamster weighs 406 grams. An important last step when you're problem solving is to always check your work and think, did I answer the big question or the problem? And does my answer make sense? We solved for the weight of the hamster, which was our big question. So we answered our big question. Does our answer, 406 grams, make sense? Evaluate. How do you know? Say your answer out loud. That's right. 406 grams makes sense because, as we said before, the problem tells us that the hamster weighs 126 grams more than the mouse, so we know that the weight of the hamster has to be more than the weight of our mouse. 406 is greater than 280, so our answer makes sense. As you jump into more story problems about weight and capacity, I'm looking for friends that look carefully at the image shown and think, what information is this image giving me about the problem? And then I'm looking for friends who are going through all of their problem-solving steps, being sure to represent neatly and carefully, and always think, does my answer make sense at the end?